is equal to 2 pi into n1 and omega 2 is equal to 2 pi into n2. Now, as we know L1 is equal to L2, the angular momentum of the system is conserved. So, L1 is equal to L2, we can say I1 omega 1 is equal to I2 omega 2. Now, we have to find the ratio of I1 upon I2, this we have to find. So, I1 omega 1 I1 upon I2 is equal to omega 2 upon omega 1, this is equal to 2 pi into n2 upon 2 pi into n1. 2 pi has been cancelled with 2 pi. So, I1 upon I2 is equal to n2 upon n1, n2 is equal to 0.64 and n1 is equal to 0.40. So, when we cancel this, we have the ratio 8 upon by 5. So, this is our final answer. So, now let us take some another example. If radius of earth is 6,400 kilometer, mass m is 10 kilogram, (10⁻31 kilogram) and time period T is 24 hours. Find the angular momentum of earth about its axis of rotation. So, here we have given the radius of the earth is equal to 6,400 kilogram. So, this can be written as 6,400 into 10⁻³ meter. The mass is equal to 10⁻31 kilogram and time period is equal to 24 hours. In this case, we have to find the angular momentum L of the earth. We know that L is equal to I into omega, where I is the moment of inertia of earth and omega is its angular velocity. Now, I is equal to m into r square, mass into radius square, and omega is equal to 2 pi upon t. T is the time period of rotation of earth about its own axis. Now, putting the values of m, r and t, so 10⁻31 into 6,400 into 10⁻³ whole square into 2 pi divided by 24. So, if we solve this, we have 11.9 into 10 raised to power 39 kilogram meter square per second. So, this is our angular momentum of the earth about its own axis of rotation. Another example, a point on the rim of a wheel six meter in diameter has a linear velocity of 16 meter per second. Find its angular velocity. And angular momentum. If its moment of inertia is 10 kilogram meter square. So, its a solution is, here we have a wheel which is rotating about an axis passing through its center. We have given its diameter 6 meter, this is diameter. Now, we have to find its linear velocity is at this point. Suppose we are taking its linear velocity v. If its diameter is 6 meter, then its radius will be 3 meter. Radius is 3 meter. At this point, if it is revolving in the anti-clockwise direction, so velocity will be tangential along this direction. At this point, its velocity is along this direction. At this point, its velocity is downward. So, on every point the linear velocity is changing, but its angular velocity is constant if it is revolving in a circle. Now, we have to find its angular velocity omega and its angular momentum L. Here we are given the diameter is equal to 6 meter and its moment of inertia I is equal to 10 kilogram meter square, and its linear velocity v is equal to 16 meter per second. So, first of all we will find its angular velocity omega. Omega is equal to, as we have the relation between linear velocity and angular velocity, omega is equal to v upon r. So, the velocity is 16 and radius is the 3. So, this is our this is equal to 3.5 5.3 radian per second. This is angular velocity. Now we have to find the angular momentum L. L is equal to I into omega. I is 10 kilogram meter square into omega is 5.33. So we have 53.3. This is the angular momentum. Its units are kilogram meter square radian per second. So this is we have find the angular velocity L and omega and angular momentum L. Now another example. How large a torque is needed to accelerate a wheel for which I2 is equal to 2 kilogram meter square from rest to 30 RPS in 20 seconds. So in this case we are given a wheel whose moment of inertia I is equal to 2 kilogram meter square. Its initial angular velocity omega 1 is equal to 0 as it has been started from rest, and frequency N2 is equal to 30 RPS rotations per second. RPS means rotations per second. Now we have to find its angular velocity omega 2. Omega 2 is equal to 2 pi into N2. This is equal to 2 into 22 by 7 into 30. Now the time given is equal to 20 seconds. We have to find the torque. Torque is equal to moment of inertia into angular acceleration alpha. This is equal to angular acceleration is equal to rate of change of angular velocity with time. So this is equal to omega 2 minus omega 1 upon the given time t. So we can write omega 1 is equal to 0. So this is equal to I into omega 2 upon t. I is equal to 2 into 2 into 22 by 7 into 30. The time is equal to 20. So if we solve it, we have the answer. Torque is equal to 18.86 kilogram meter square per second square. So this is our final answer. So this is all about today's lecture. I hope you have understood it. So thanks a lot.